Alright guys, today we're working with the same identities again, but now instead of being given the angle measures and having to find the exact values on a unit circle, you don't know what the angle measures are, but you're given the exact values. And so you would just plug them into the equation. So you're kind of bypassing the middleman almost with the angle measures thing. So let's look at this here. As an example, you know that sine of A is equal to 3/5 and A is in quadrant 1. You know cosine of B is in quadrant 3 and it's equal to negative 3/5. So if we draw out our angle measures, I would recommend drawing them. Make sure you label the angles because that actually makes a big difference for when you're plugging these things in. A lot of people will make that mistake where they'll use the measures from the wrong triangle because they weren't real careful in labeling everything. So we have B is down there. It's kind of a goofy looking B. Oh well. Negative 35. So you're going to want to find the other side lengths here. So in this case, I made it easy. I'm using Pythagorean triples. Okay, so we have our triangle set. So now we need to find cosine of A plus B. So that equation, if you don't remember, is right there. Cosine of A, cosine of B. So all we're doing here is we're just going to find the cosine of A first. So we go to our A triangle and we find cosine. So that should be 4/5. We then go to cosine of B. So we go to our B triangle. Cosine is negative 3/5. We then go to the sine of A. So A triangle, find the sine, which is 3/5. And then sine of B. So we go to the B triangle, negative 4/5. Okay, so that's times negative 4/5. Then we simplify, and that's basically it. So you get a negative 12/25. Now here we have a negative 3/5 and a negative 4, so that's plus 12/25, and that nets us 0. So that's it. That's the basics of what we're doing today. Let's look at another one. So again, same triangles as before, so I'm just going to copy these over. Okay? So we want to find the sine of A minus B. So we look at our equation, and we just plug in the correct parts. So sine of A. So sine of A, go to A triangle, sine of A is 3/5 times the cosine of B. So B cosine negative 3/5 minus cosine of A. So A cosine is 4/5. And then sine of B, negative 4/5. So then multiply together, we have negative 9/25 plus 16/25, which gives us a whole 7/25. Now I'll say these are real simple because the triangles all line up. Not always going to be the case. Like sometimes you'll end up with goofy numbers and radicals, but just for when we're first starting this, I wanted to try, simpler to begin with. Alright, so now sine of A is 3/5, we'll say in quadrant 1. Cosine of B is negative 4/5 with B in quadrant 2, or quadrant 3. We're going to find tangent. I'm going to give you a hint to write small because this one's kind of a doozy. Alright, so we know we're going to have to find the sine of A plus B over the cosine of A plus B. Okay, so right now, let's draw our triangles, and I want you to try to find the sine of A plus B and the cosine of A plus B like we just did. So the first triangle will go here, and that's 3/7. So then we find our missing side length. So mark that as an A. So that'd be 49 minus 9 is root 40, which is 2√10 when it's all simplified. Okay, that's obviously not fun. Okay, so all I did here is that 7 squared is 49, minus 3 squared, which is 9. So that gives me 40, take the square root. 4 and 10, so 2 root 10, okay? And then cosines in quadrant 3, of course, for b. So then it's not as bad. Negative 4, that's 5, so this would be negative 3. That's my b triangle. So right now, pause the video, try and see how this goes. I want to see if you can figure it out, at least to getting the sine and cosines done. Alright, so you should have something that looks like this down here in the bottom, where you have, well, you simplified everything. So once again, try that. I want you guys to try multiplying by the conjugates, and let's see if we can come up with the right solution. Alright, so you should end up with 150 root 10 plus 588 all over 559. I promise the ones on the test usually aren't that bad. I mean, the numbers are a lot nicer. I just want to give you something like this because this is a worst case scenario where if you can, muddle your way through this, you should be in pretty good shape. Alright, last but not least, we're going to do a proof. Of course, since we do proofs a lot. So we want to fix that guy here on the left. It's the most complicated side. That's a sine of an a plus b equation. Hopefully you recognize that. So then that's going to be sine of pi cosine of x minus cosine of phi sine of x. So it's all written out. One thing to look at here. Oops, I think I wrote that equation wrong. Yeah, it's a plus. Oops. That should be a plus. Sorry, guys. Okay. Now let's look at the unit circle. One thing to keep in mind here. This and this, we have no idea because we don't know what x is. So we're just going to leave those alone. We're going to focus on the sine of pi and the cosine of pi. So on the unit circle, at pi, cosine is negative 1. So we have negative 1 times the sine of x. Sine is 0, so you have 0 times cosine of x. 0 times anything is 0, so that just leaves us with a negative sine of x, which equals check mark. That concludes the notes for today. Hopefully it makes sense. And once again, taking a look and watching the video and then seeing it again in class makes it a lot easier. I mean, this stuff is a lot more complicated, and it's going to require a little extra work to make sure you understand it fully.